everyone, welcome to the first lecture of machine learning, which is linear regression. So I hope you have done some review on the theoretical part of linear regression. So today we're going to focus on how to call the scikit-learn library to create a linear regression model and how to predict and then evaluate the model at the end. So that's I'll say the basic procedure for machine learning, and we're going to use that a lot in the future classes. So don't worry too much about data cleaning. We're going to mention that later in, let's see, maybe logistic regression model, okay? So the data set we use for today is from your neighbor for housing prices. So your neighbor is a real estate agent and wants some help predicting housing prices for regions in the USA. So it would be great if you could somehow create a model for her that allows her to put a few features of a house and returns back an estimate of what the house would sell for. So she has asked you if you could help her out with your new data science skills. You say yes and decide the linear regression might be a good path to solve the problem. So your neighbor then give you some information about a bunch of houses in regions of USA. So it's all in a data set called USA underscore housing.csv. Okay, so let's get started. So first I'm gonna check out the data. I am gonna create a variable called the USA housing pd.read csv and its name is called USA housing.csv. Okay. Oh wait, sorry, I had two double quotes here. All right. So how about let's take a look of the data a little bit. So here we got several columns. So the first one is average income of residents of the city the house is located in, okay? And the second one, the average age of houses in the same city. The third column, average number of rooms for houses in the same city. And this one, average number of bedrooms for houses in the same city. Average population of the city that the house is located in, and price is the price of the house, and the last one, the address of the house. Okay, so I would suggest you when you receive a data set like this, let's do some basic exploration, I would say. So first one, maybe we can use the method called info. Okay, so what we got here, we got total 7 columns, and you can see except the address here, everything here, they are numeric data, right? Okay, and what else can we use? Describe. Okay, so describe method gives us the count, the mean, standard deviation, minimum, maximum, and some quantiles. Okay, and also we can use something called columns. Okay, that gives you all the columns in your data set. Okay, and I always suggest you to create some simple plots to check out the data. So if your data set is not too big, too complicated, I will suggest you to use the pair plot. And you can see we have a lot of numerical data here, right? So pair plot might be a good choice. So here, just passing the data frame's name. Okay, it might take some time. So for pair plot, it's not only give you the scatter plot for the relationship between all the pairs of variables, and also give you the histogram for each of the columns here. So here you can see if we read the distribution plot here, you can see everyone seems like normally distributed, except this one. This is called average area number of bedrooms. Okay, but it actually makes sense when if you go back to read this I would say the scatter plot here. So you can see it's being divided to 5 segments. It kind of makes sense. You can't have bedroom that is 2.5, right? So it's 2, 3, 4, 5, 6. Okay. And also I would suggest you to use. Okay, so for this one, if you just read the scatter plot here, it might hard to figure out if they have any correlation between the relationship between each other. Seems like this one, uh, the the price versus average area income. So we could use something to help us. I'll say U as a housing dot CORR. That's the for correlation, right? Okay, so it gives you the numeric number of that. And if you feel like it's hard to read, we can put that in a, what, heat map, right? Heat map. So put this one in a heat map. That will be, that's what we get. Okay, so you can see the this one is actually makes sense because you're always 100% related to yourself. So this diagonal line here, they are 1. And the rest of them, we can refer to the color scale here. So to make that more clear, I will add a annotation. So we'll return some numerical number here of the real correlation coefficient. Okay. So that's the basic EDA, the exploratory data analysis, every time when you receive a new data set.